Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, rotate a linked list. Okay, so what the problem is saying is we'll be given a singly linked list. Okay, and we want to rotate the linked list. Okay, into the left directions k times. Okay, k times. So whatever is a k given, so we have to rotate the this particular linked list, right? This particular linked list in the on the left side by k times. So how it will look like by k times, meaning in this example you have to rotate the linked list on the left side by 2 times. So how it will look like? So on the left side, right? So 2 times if we rotate, so 30 will be the head, and then these two elements, right? Since we are rotating 2 times, so these two elements will come after the last element. Okay. So our linked list will look like this. Okay. We have rotated the linked list twice. Okay. Or 2 times. Or 2 times. Okay. So this is the ask. Now, how can we solve this problem? Okay, so for a demonstration purpose, I'll take this k as 6. Okay, so let's say when this k equal to 6, right? When k is equal to 6, so how will the linked list look like? For example, here the elements in the linked list here are 4 only, right? And we want to rotate the linked list 6 times. Okay, we want to rotate the linked list 6 times. So for example, let's quickly write how to look like. So if we rotate first time 20, it will look like 20, 30. 40 and 10 will come after, right? And like this, right? The second time, this is CNT, count equal to 1, right? Then second time will be 30, 40, 10, 10, 20, right? This is second iteration. Then 40, 10, 20, and 30, right? This is third iteration, right? Then what? 10, 20, 30, 40. This is fourth iteration. So if you have a look after fourth iteration, the list is looking like original one only, right? The list is looking like original because there are four elements. Because there are four elements in the linked list, and if we rotate the linked list by 4 times, then it will come to the original position. Okay, it will come to the original linked list. Okay, now since we have to go till k equal to 6, so again, how it will look like 20, 30, 20, 30, 40, and 10, right? This is fifth time. And what will be the sixth time? 30, 40, 10, and 20. This is a sixth time, and we will stop here. So how our linked list looks now? Original was 10, 20, 30, and 40, right? And now it is after rotation, after rotating 6 times, it is looking like this. Okay, it is looking like this. So it is what? This linked list also looks like this one when we rotated the linked list 2 times, right? When we rotated the linked list 2 times, if you see 30, 40, 10, 20, here also 30, 40, 10, 20. Okay, so it is the same. So for such cases, right, wherein the wherein k is greater than length, what we are going to do is we are going to use this formula k equal to k mod length. K equal to k mod length. Length is nothing but the length of the linked list. That is the number of elements of the linked list. So in this example, in this particular example, how many elements are there? There are 4 elements. What is k? K is 6. If you do mod means what? We are doing division and we take the remainder and we are taking into the k, remainder k. So when we do 6 mod 4, what will be the answer? It is going to be 2 because 4 ones are 4 and remainder is 2. So k equal to 2, right? So when we say k equal to 6, if we do the mod, so it means anyways anyways proven, right? We have already anyways proven when we rotated 6 times, so it looked the linked list looked like when we rotated the linked list 2 times basically, and that is why we are going to use this formula whenever k is greater than length greater than the linked list length. Okay, the linked list length. Okay, so this was an example. Now let's see how we are going to solve this problem. Okay, we are going to use this intuition. Okay, so what we are going to do first of all, let's say this is the linked list 10, 20, 30, 40. So this is our linked list, right? And what was k? K equal to 6. So what we're going to do, we're going to take a current pointer. Current pointer is pointing here. Okay, and we are going to take length equal to 1. We want to calculate the length of the linked list. Okay, we want to calculate the length of the linked list. Okay, in order for this formula, right? For this formula. Okay, so we are going to have a current pointer which will be pointing with along with head. So what we are going to do now, we are going to keep on moving till current dot next is not equal to null. Okay, we want to go till the last element. Okay, we just want to go till the last element and stop. So here current is pointing here, length is 1. So now we're going to go into the while loop wherein current dot next is not equal to null. So we are going to update our current. Current is pointing here. We'll update our length 2. We'll update our current. We'll update our length 3. Right? We'll update our current. We'll update our length 4. Okay. And we'll stop here because current dot next is null. Current dot next is null. So we we also wanted to go to the last element. Okay. So length is 4. Okay, now we are going to calculate since k equal to 6, right? So we have to calculate the k now. Okay, so we're going to use this particular formula only. So k 6 mod length is 4. We have calculated here 4 and k equal to what? 2, right? Now k will be 2. K will be 2. Okay. Also, now what we're going to do here is we are going to since now we have current which is pointing at the last element 40. Now what we are going to do, let me now write again this 20 10 20 30 40, and this is our current, this is our current, this is our head. Now what we are going to do, we are going to connect the next of the last pointer to the head. Okay, we are going to make it circular. So current dot next we are going to tell equal to head. This is a second step. Okay, current dot next we are going to tell head. And then what we are going to do, we are also going to update the current. We will point current to the head position. So we will say current equal to current dot next. So current will point to this particular to head. Okay, to head. Okay, now this is the state. Now what we are going to do, we are going to reach till kth node. What is that node? K equal to 2, right? K equal to 2. So we want to reach till kth node. Current is pointing here. Using current, we will go till kth node. Okay, that is a second node. That is a second node. So what we are going to do, we are going to have one variable kth node equal to 1. Okay, and now we are going to have a while loop. Okay, okay, so what we'll do, let me code till here so that I'll explain the step and then I'll code that particular step as well so that you'll understand. So first I'll show the Java code followed by C++. Just one request, I'm making it very easy for you. Okay, just one request to please subscribe to the channel, like the video. Okay, so first of all, as I said, let's calculate the length of the linked list. Length equal to 1. Okay, and we'll take our current equal to head, we'll say, right? Now what I said, the first step is current dot next will go to the last element. Okay, current dot next is not equal to null, we'll go till the last element, and then we will say current equal to current dot next. So I'll show the C++ code as well, post this, and we'll increment a length. Okay, now once this while loop breaks, our that means um, we have reached to the last node. Okay, we have reached to the last node. So now we have length. Okay, now what are we going to do? We are going to use a formula k equal to k mod length, so that if the k is bigger than the length, then we'll have the right k. Okay, now this is done. Now second step is what? We want to connect the last node to the first node, which is head. Current dot next equal to head. Okay, and then we are going to go to the head. Current, we'll say current dot next. That means current will point to the head. Okay. Now we want to go. So this till here we have coded. Till here we have coded. Okay. Now we want to go to the kth node. Okay. We want to go to the kth node, right? So we have a kth node variable which is 1. Now what are we going to do? We are going to update a current pointer, okay, to the next, and we will increment a kth node. Okay. Now what will be the while loop? While loop will be kth node should be less than k. Okay. Now since kth node is 2, which is equal to 2 and not less than 2. So this while loop will break, and that means our current pointer will point to the kth node, which is second node. If you see, it is indeed pointing to the second node, first and second, right? Second node. Okay. So once this is done, let me also code this. So int kth node equal to 1. Okay, in kth node equal to 1, while kth node is less than k. Okay, so what are we going to do? Current equal to current dot next. Okay, and we'll increment our kth node as well. Once this while loop breaks, current will be pointing to the kth node. Okay, once it is done, Once it is done, so what are we going to do now? We will we will mark whatever is the next node of current node, right? Whatever is the next node of current node with head. Okay, with head. Okay, with head. Because this will be the new head. We'll see how it is. Okay. And the second step would be once we have marked this next current dot next as a head, we will also uh, we'll also assign current dot next as null. Okay, current dot next as null, which is what? Current is what? 20, right? Current dot next will point to null. Okay, will point to null. So we'll see how it will look like, right? So for example, if you see 30 is a new head, right? So let me write 30, 40. And anyways, 40 is connected to 10, the older head, right? The older head, right? 10 and 20. And also now what we've done, current dot next is equal to null. Current dot next equal to null. And this is a head. So this will be a final output. If you see, we have rotated, right? What was the original linked list? 20, 10, 20, 30, 40. K was 2, right? It was 6, but with a formula, it became 2, right? Okay. And then if you see, so when K equal to 2, yes, we have rotated the linked list, right? By 2 times. So that means we have pushed this two elements, the first two elements or first two nodes at the last, right? At the last. So 30, 40, 10, 20 is the final output. So let me write quickly. So head equal to current dot next, and current dot next equal to null, we'll say. Okay, let me just return head. I think this should be done. Let me, oh yes, one more thing, we need to handle one more step. What is here? Cannot find symbol. Kth node. Okay, so here it was capital. Let's compile. We want to handle one more case. If k, for example, if k is 0, right? If k is 0, that means no need to rotate, because the it will be original list only, because it is going to be original list only, right? After rotation, it is going to be original list only. So we'll simply return head if k equal to 0. Let me now compile this again. We'll also discuss the time complexity and space complexity. Let me submit this. So test cases are being processed. Let's discuss the time complexity. The time complexity is going to be O of n, because we are rotating the linked list, like we are having one while loop or for loop, right? It is one while loop only. So it is taking O of n here, then it is taking O of n. So for larger elements, right, it is going to be O of n on the high side. Okay. And space complexity is O of 1, because we are not using any extra space. Okay. So thanks for watching. Okay. I hope you have got the solution. Please don't forget to subscribe to the channel, like the video. Okay, so let's quickly see the C++ code, which is almost same. Okay, not much difference. I've already explained this with each step, right? With each step, I will already explain this. Okay, so I'll attach the code into the description section so that you'll understand. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.